in this example, we're going to look at writing the molecular equation, the complete ionic equation, and the net equation for two different reactions. So in the first reaction, we have chromium sulfate mixing with ammonium carbonate, and so we need to predict the products for the molecular equation, then the complete ionic equation, and then the net ionic equation. So first, we want to start by writing the complete ionic equation for the reactants, and so that would be 2 chromium. And so if you're not quite sure of the charges, you can kind of figure that out. And so chromium sulfate is a 2-, and there are 3 of those, so that's a -6 charge. And there are 2 chromiums, which is a +3 charge. These are both in aqueous solution. Okay, so then we're going to add to that at least 2 ammonia, 2 NH4+, plus CO3 2-. These are still aqueous, okay? And so as we decide to mix the products, we know that these are going to swap partners, and so there are 3 sulfates and 2 ammonia, so we already know that this is going to be an unbalanced equation, and so as we predict the products, it's going to end up being 2 ammonia for every 1 sulfate. All right, and so let's work on balancing these. And so we know that there are already 3 sulfates, which means there has to be a 3 here, or there might possibly be a 3 there. We're not quite sure yet. So let's look at the other product. Okay, and so we have chromium 3+ with carbonate, and so that's going to give us chromium Cr2, CO3, 3. And so we don't know if either of these are solid just yet, but let's go ahead and balance this chemical equation. So there are 2 chromates on both sides. Okay, the sulfates are unbalanced, so there is a 3 here. So then there are 6 ammonia, and we're gonna need 3 of those, and so we'll add a 6 here, okay? And so if the question asked you to, you would have to rewrite this using all of the balance states. In this case, we'll leave it as is. Now we need to decide which of these is soluble and which of these is insoluble. It turns out that the solubility rules state that ammonium sulfate is soluble, and so this will be an aqueous, and this is going to be our insoluble product, okay? And so now we need to write these out, but we need to go back and verify that these are all balanced. And so there are 3 of these, and there are 6 of these. And so now we're going to have 6 ammonia, aqueous, plus 3 sulfates. So I ran out of space, so we're going to go ahead and just write our solid on the line below. Now solids, because they are solids, do not ionize, so they do not separate in the complete ionic equation. So now, using a red pen, I'm going to go ahead and mark out any of the things that are observed on both sides. So we have 3 sulfates on both sides, and we have 6 ammonia on both sides. So our net ionic equation is going to be 2Cr3+ aqueous plus 3 CO3 2- aqueous forms Cr2 CO3 3 solid. So this is our net ionic equation, this is the complete ionic equation, and this is the molecular equation. So what about for our next example, where we have iron nitrate mixed with potassium hydroxide? Okay, so we'll start with the complete ionic equation, where the Fe2+ aqueous interacts with 2 nitrate ions plus a K+ aqueous plus an OH- aqueous. Okay, so now we need to swap partners, and so this will give us a potassium nitrate. Okay, now with this one, we're going to end up with an FeOH2. Okay, so we know that these are unbalanced, and so in this case, we have 2 nitrates, which means that we need to have a 2 in front of this, and there are 2 hydroxides, so we're going to add a 2 here. Okay, so we'll have a 2 here and a 2 here. Now, we need to determine what is soluble and what is insoluble, and so nitrates are always soluble, so this is going to be aqueous, and that will make the iron hydroxide a solid. So in this case, we're going to have 2K+ aqueous plus 2NO3- aqueous plus FeOH2 solid. Again, we're going to mark out anything that's on both sides so we can determine what is going to be our net ionic equation. The nitrate ions are the same. The potassium ions are the same. So our net ionic is going to be Fe2 plus aqueous plus 2OH minus aqueous goes to FeOH2 solid. So this is a net ionic, this is a complete ionic, this is the molecular equation.